video in interference and what it is exactly and where we might see it in our daily lives. So interference is basically whenever you have two waves that come in contact, as I say right here in this top right corner, and then it also describes how they interact with one another. And so in this concept, we see that we have two types of interference. We see that we have constructive and destructive. And one thing to know is that in each of these types, we will see an in phase and out of phase interactions with one another, and we're gonna explain that in just a second. And so I use these in my last video, these waves, and they seem to work pretty well. And so that's why if you're looking at this again, that's why it looks pretty similar. So first, let's talk about constructive in phase, because it's really easy to see. So if we take constructive in phase, what we're going to do, we're going to take this guy right here. We're going to use our cut tool, and we are basically just going to copy him over here. So what do we see? We're going to take him. We're going to lay it right on top, right here. And so when we lay it on top of this, when we match these waves up, we can see that we create that they match basically, and they will create what's called a constructive interference. And what that basically means, we're just going to leave that. Actually, we're not even going to leave that right there. We're going to put him over here. We're going to delete him. So let's just imagine that we have that we've laid this source 2, basically, or the whole source, that we've laid this on top of that. Okay, so let's just imagine that. When we do that, get another pen color. When we do that, we will see an increase in amplitude. And so our amplitude is basically just going to come all the way up. So our wavelength, which is constituted by the distance between our peaks, right? Our wavelength is the same. But the amplitude, or the distance between the peak and the valley, which the peak or the valley being right here and the peak being right here, is now a lot bigger. So that means it's a larger amplitude, which basically means it's just louder now. And so let's go back with out of phase, or what was called pi shifted. That's basically the same thing. When you hear out of phase or pi shifted, you just think of the other. They're synonymous in what we use. So pi shifted, out of phase, pi shifted. So what that basically entails, let's go back to our scissor tool. What it's talking about when it says out of phase is that just means that the waves are they don't start from exactly the same point in the source, or they're just, it's hard to, oops, that kind of messed that up. Sorry guys, do that again. Anyway, so what out of phase basically means is that when we take a source that has the same wavelength or similar wavelength or whatever, and let's just lay it over top, we will see that it doesn't match up when we're at the exact distance of the source. And as we kind of jump forward and forward, or more forward, we see it's still out of phase. And so basically, when we see that it's out of phase like that, when we see that it's out of phase like that, we can see how it's the exact opposite of what our in phase was. And so the only thing we can actually deduce from that is that, well, they're interfering with one another. And if they're interfering with one another, then they will be canceling each other out, which essentially would be destroying them, hence destructive interference. So destructive interference is basically when two waves or two wavelengths that are coming from similar sources, but they're out of phase of one another. Destructive interference tells us that they're basically canceling each other out. And so with that, we talked about before how you can have you can have constructive interference with in phase and out of phase, and you can have destructive interference with in phase and out of phase. So let's go down and let's do that real quick. So we'll talk about this little piece of this little piece of mathematical knowledge here in a second. It's not super complicated. It's not, no need to focus in on it. It's not essential or complex in any way. It's more of just to show you when you would see in phase, when you would see constructive or destructive interference, as you can see it, the blue text on the right. So let's do what we did before. Get our copy tool, copy, paste it. All right, so let's take this wave again, lay it right on top. So we know that when let's just call it the distance. When the sources are at the exact same point, okay, we know that they're going to be in phase of one another, or we know they're in phase of one another, and when they're at the exact same point, we know they're going to be constructive. So if they're in phase, if they're at the same point or from the same point of the source, so basically if you take two speakers and you put them right on top of each other, and you play the same sound, the same basically volume per speaker, you will create an in-phase constructive sound, which will make it louder. So add a speaker, make it louder, makes sense. So if we see that and we go down and whatnot, we show that's the same case as long as we increase the distance by a certain amount. And so let's just leave that right there. I'm not going to do too much right there, but leave that right there. I just set it off so we can see both waves. And so if we see how we increased this distance right here by an entire wavelength, okay, so essentially we're not changing the wavelength, we're just saying, okay, so the wavelength is this amount. And so if we increase it by the same wavelength each time, then we will basically keep in our constructive interference idea. And so if we do that, we can see how right here again, same wavelength, right? Same wavelength, because we know wavelength is the distance between the two peaks. And so that's how we see constructive interference. So if we come down to this little blue text down here, the constructive, and we go to the right, it says delta x. Delta x is just to represent the distance away from the sources. And so if we see 0, that means they're the same point, basically. The sources are making or projecting a sound from the same point. But if we see lambda, that means that, well, we've just increased the distance by basically lambda, by what lambda is. And so if we have 2 lambda, same thing, it's just by 2 times the lambda. So let's go back again. So if we take, this would right here would be 0, right? So with constructive, this would be lambda, this would be 2 times lambda, 3 times lambda, and so forth. And that's basically all it is. Pretty easy. Don't overthink it or anything like that. And so with destructive interference, so we know that when they're in phase and they're coming from the same point right here, just like this, they're constructive, right? So they're they build, they kind of build on top of each other to make the sound louder. But what happens when we only increase by half a wavelength? You see how when we increase by half a wavelength, the first time anyway, it creates a destructive interference. And so from then on, we can't just say that we increase by half a wavelength every time, because we increase by half right here. We increase by half from the point source. Okay, we increase by half, boom, destructive. But we increase by half again, boom, constructive. And so basically, from the first point, they're in phase, but the sources are half a wavelength away from each other. About half a wavelength away from each other, then they will be destructive. And it's kind of difficult to really show you just because these aren't quite on par with being exact to one another, but you get the idea. So the first time you increase by half, then you go to 1/2, then 2/2, then 3/2, and so forth. So let's go show you, delete. So right down here in the second, the destructive right here, okay? We have the x minus x, yada, yada, yada. So if we can see this, it's lambda divided by 2, so half of lambda, right? And then that second one that I showed you before, let me do this again, kind of just show you one more time. So the second one, okay, so that's lambda over 2 right here. This would be 3 lambda over 2, so basically 1/2 lambda, or 1 and 1/2 lambda. This one is going to be 5 lambda over 2, which is 2 and 1/2 lambda, and so forth and so on. And so that's basically all you need to know as far as the mathematical, quote-unquote, part for that. It's not complex. Don't hurt yourself trying to figure that out, because it doesn't matter that much. All right, so pi shifted out of phase. So when are we going to see, we know we see destructive interference with pi shifted out of phase. We know that. We're not going to go over that again because we already did. We will go over when you'll see it as far as the distance. So when you increase by the distance, it follows the same suit as the in phase does, in the sense that it stays destructive as you increase by the whole integer. So destructive, you increase by one whole wavelength, destructive, another whole wavelength, destructive, another whole wavelength, destructive. But our question isn't really pertaining to what we really do. We know that. That's pretty simple, but what we don't know right now is when we're going to see constructive. And so with constructive, it also follows the same suit with the in phase, because the in phase up here, we know the in phase up here. Oops, I gotta get my pencil. We know that this, when that is laid over that by half of the wavelength, then it's going to start being destructive. And so it's basically the opposite with our pi out of phase. So if we overlay this by half a wavelength, it creates a constructive interference. And the same thing, as you increase by another wavelength, it creates constructive interference. Constructive interference, constructive interference. And so as we do that, let's just put it right here. Let's copy it real quick. So as we do that, we're increasing it by, first we increase it by half a wavelength to make it constructive, and then we continue to increase it by a whole wavelength after that to keep it in that constructive, phase or interference. And so we can see it right here. I'm going to go back. Okay. We can see that right here. Let's get my pencil again. As you increase it by half, and then 3/2 lambda, 5/2 lambda is constructive. So it's literally the exact opposite from in phase, right? So in phase, constructive. In phase is constructive as regular as you increase by whole integers, and then in phase destructive when you increase by half an integer, and then you continue to increase by a whole wavelength after that, keeping it at the half wavelength point. And then the opposite is true for the out of phase.